Hey, it's Mr. Leatherwood.
And Miss Costello.
And today we're talking about inequalities. And yeah, ready?
Yay.
Yay.
When I say yay.
Do they?
Yeah.
That's
They
good.
laugh.
To solve an inequality means to determine the value of the variable that makes the inequality true. This is very close to what we've been doing just in regular algebra, which you'll see here in just a second. So let's do a couple of examples. You want to talk?
Sure.
I can talk the whole time.
No, we could both talk. I was
Okay.
just waiting.
So,
Okay. So the difference between these two inequalities right here is basically how they're going to look on a number line. So you notice that when we graph the first inequality, x is greater than 8. Well, first we got to set up our number line. So set up some numbers.
okay.
Okay, so if x is greater than 8, we're going to start at 8. And we're going to make a circle.
Make a circle.
Okay, and we're not going to fill it in?
We're not going to fill
We're
it in.
not going to fill it in.
Because it doesn't equal 8, it's greater than 8. So it's
Right.
going to be everything.
And it's going to be everything greater than 8. So our arrow is going to point to the right.
But it is not going to include 8. So that's the reason that we do a circle without it filling in. Because it's going to be everything greater than 8 going this way.
Yep, so if you do not have an equal sign along with your, what's it called, an arrow?
Mm-hmm.
Or
I guess technically
greater
it may
than
be an
or
array,
less
but
than
yeah.
sign,
Mm-hmm.
you are not going to fill in the hole.
Okay.
It's going to be an open hole.
So on this one, it's going to be a little different. Let me write in my number line. Should have done this earlier. 11. So this one says that it is greater than and equal to 8. So since it's equal to 8, we're going to color in the dot.
So we're going to have a filled in hole.
So that says it's 8 and everything greater than 8. So that's what the two differences between having just a greater than symbol and a greater than and equal symbol.
Yep.
Okay, so that's graphing an inequality. This should be a review from 6th grade. Now let's look at solving for an inequality. All right, so we have 2 here. And so the reason I said earlier that it's a lot like what we've been doing in algebra is because you're going to do the exact same things we've been doing in algebra is isolating the variable.
Right, we're basically going to solve for x.
Mm-hmm. So on our first one over here, we're going to do the reverse or the inverse operation. So we're going to subtract by 21 first.
From both sides.
Mm-hmm.
You're going to treat your greater than sign right now as an equal sign.
Right.
Kind of.
And so that leaves 7x is greater than, what
7.
is that, 7?
Mm-hmm.
And then we're going to do,
Sevens are awful.
they are,
Fix them.
what do you mean? Do you want me to do that?
There you go.
So they're
Well,
not
it looked like a greater
a greater
sign.
than, maybe
Yeah.
my greater than sign was awful.
Maybe they're both awful.
Okay, maybe so.
Okay.
So then I'm going to divide by 7 to isolate my variable. And I'm dividing by a positive 7. It looked, maybe you'll write next time.
I will.
So x is greater than, they do look alike.
Yeah, do.
Greater than 7. Okay? I want you to notice, because this is going to be important in a second, I divided by a whole number or positive whole number here,
Mm-hmm.
and this sign stayed the same,
Right,
which you're going, what does that mean? But you'll see in just a second.
right. And so now we know that our solution can be anything greater than 7.
Right.
So basically, if we plugged in any number for x that is greater than 7, our inequality would be true.
Mm-hmm. And since it is greater than 7 and not equal to 7, we would draw a circle and then everything greater than 7. Just to refresh your memory there. All right. So now let's look at the other one. Want to walk us through it, Ms. Costello?
Sure.
Okay.
Okay, so first thing I have to do, I'm isolating my variable, so I subtract 21 from both sides. 21 cancels out. I'm left with negative 7x is greater than 7.
Yay.
Okay, it was a
Sorry.
little better.
A little better.
Okay, so Now I have negative 7x is greater than 7, so I'm going to divide by a negative 7 on both sides. Okay, but now, well, let's bring down our x.
Okay.
So x, and since we divided by a negative number, our inequality sign is actually going to flip. So it does not stay as greater than, it turns to less than. And then we would write negative 1. Negative 7 divided by negative 7 becomes negative 1. So basically what we want you to learn that is anytime you have to divide or multiply across the sign or on both sides of the equation, your sign is just going to flip to the other sign.
So if you multiply or divide by a negative, it's going to do that.
Yep.
And so it's going to be less than negative 1, not equal to, so less than, so we're going to do this, oops.
So open hole.
Open hole. And then everything that's less than that.
Yep.
Okay. Let's see how that works on a couple more examples. All right. So this time, didn't do much changing, but I have greater than and equal to this time. So
we're going to
go ahead.
add 4.
Add 4 to both sides.
So I'm left with 3x is greater than or equal to 12.
Then I'm going to divide by a positive 3.
Yep.
So my sign's going to stay the same. It's not going to flip this time.
Because we did not divide by a negative.
Right. And so we have x is greater than or equal to 4. So if I did my number line.
That is such a straight line. Your lines have been so awesomely straight.
I try.
Yep.
So it's greater than or equal to 4. So this time I have a solid circle. And then everything that's greater than that. Oops, didn't go all the way. Here we go. No? Don't do that.
Yeah, no.
Yeah, don't do that.
Don't be weird.
Okay. All right, last example, and then we'll let you go.
Okay. So we're going to do the same thing. We're going to add 4 both sides. So I'm left with negative 3x is greater than or equal to 12. And now we are dividing by a negative 3. So now, remember, our sign's going to flip. So now we're left with x is less than or equal to 12. Not 12.
Oh, sorry.
You didn't put it.
My bad.
4 becomes 4.
Just ignore that. Negative 4.
Negative 4.
Negative
Oh my
4. We're all over the place.
gosh.
All right, so x is less than or equal to negative 4. So if we drew our little line, bloop. Let's do negative 4 here, negative 5, negative 6. So it is equal to this time,
So it's a filled in circle.
filled in circle, and then it's less than, so we're going to the left. And that's it. And we have a cool little story that we can tell you why, to give you some explanation of why this flips when you either multiply or divide by a negative. So we'll cover that in class. All done?
Yep, we're done.
Later.
Bye.